So let's look at multiplying and dividing in scientific notation. We've already looked at adding and subtracting, which we didn't really need to use exponent rules for, but here we're definitely going to need to do that. So with multiplying and dividing, the best thing that we can do for ourselves is regroup the problems into easier, chunkable parts to work with. So what I'm going to do, I know that when I'm working with fractions, I know that I can take multiplication, like 1/2 times 3/4, and multiply the numerators and multiply the denominators. So I could rewrite it like this: 1 times 3 over 2 times 4, or the same thing as 3/8. So since I can go in that direction of taking a fraction and working it together into one, I can also go in the reverse direction of taking a fraction and break it up into smaller pieces. So that is what I'm going to do here. I'm going to take this problem and break it up into its two constituent parts. I'm going to rewrite it as 1 72/100 divided by 4 times 10 to the 0th power divided by 10 to the -3rd power. So we know that these two things are equal because if I were to multiply them, I could multiply their numerators and multiply their denominators, which would give me exactly the statement I started with. So I know that it's okay to do. Now these are two things that I can evaluate, which is why breaking it up is helpful. So I can calculate that 1 72/100 divided by 4 is the same thing as 43/100. And I know that using my quotient rule, that when I'm dividing with the same base as we are over here, I need to keep my base and subtract my exponents. So I can rewrite that piece of the problem as 10 to the 0 minus -3, or better written, 10 to the 0 plus 3, or even better yet, 10 to the 3rd. My only problem here is that this final answer is now no longer in scientific notation, even though both my numerator and denominator of my original problem were. So what I need to do is I need to readjust that power of 10. If I move this decimal one place to the right, that means that I'm making that number, 43/100, bigger by a power of 10, going from 43/100 to 4 3/10. So because I'm making that bigger by one power of 10, that 10 needs to come from somewhere. So I need to lower this by a power of 10, rewriting it as 4 3/10 times 10 to the 2nd power. Multiplication works much the same way, where it's really helpful to regroup it. But as we see over here, the original problem is not written entirely in scientific notation. So I need to change that second factor to be in scientific notation. I know that my decimal is in its starting place, but I want it to end there with one digit before the decimal. So I need to move that decimal 1, 2, 3, 4, 5 places, which means that I can rewrite this problem as 2 times 10 to the 6th times 9 times 10 to the -5th. Now, the nice thing about multiplication is that order doesn't matter and grouping doesn't matter. So those parentheses really aren't making a difference here, and I can regroup it to be more useful, just like we did in the division problem. So I can regroup this as 2 times 9 times 10 to the 6th times 10 to the -5th. From here, I know that 2 times 9 is 18, and 10 to the 6th times 10 to the 5th, using my product rule, that says that when I am multiplying two things with the same base, I add the exponents. I can rewrite that as 10 to the 6th plus -5, or even better yet, 18 times 10 to the 1st power. Now, just like the last problem, I have the same issue of it is no longer in scientific notation because this is a 2-digit number over here. So thinking about where its decimal is, I need to shift that decimal one place smaller. So, which means I'm taking it from 18 to 1 8/10. In other words, I'm making it 1 power of 10 smaller. So that 10 needs to go somewhere, and to balance it out, I make this 1 power of 10 bigger, which means I can rewrite it as 1 8/10 times 10 to the 2nd power. My final answer. Let's do one more where we're looking at this in a real world type problem. So it says the volume of the Atlantic Ocean is about 3 1/10 times 10 to the 17th cubic meters. The Mississippi River has an annual flow of 6 3/10 times 10 to the 11th cubic meters. What we are trying to figure out is how many times would the Mississippi River's annual flow fit into the Atlantic Ocean? In other words, it's asking us, the Atlantic Ocean is how many times as large as that Mississippi River? So if I want to figure out how many times, I want to figure out what it's being multiplied by. And when we want to figure out what something's being multiplied by, we divide. So what I'm going to do is I'm going to take the volume of the Atlantic Ocean, 3 1/10 times 10 to the 17th power, divided by that annual flow of the Mississippi River, 6 3/10 times 10 to the 11th power. So remember, whether we're multiplying or dividing, it's really helpful to regroup the problems. So I'm going to rewrite this as 3 1/10 divided by 6 3/10 times 10 to the 17th power divided by 10 to the 11th power. And these are both things that now I can calculate. I can do 3 1/10 divided by 6 3/10, which gives me a really kind of ugly number. It gives me 0.492, so on and so forth. So I'm going to go ahead and round that to 492 thousandths. And I'm going to divide 10 to the 17th by 10 to the 11th, which, using my quotient rule, keep the base, subtract the exponents, can be rewritten as 10 to the 6th. Now, not in scientific notation, so I need to get it there, which means that I need to shift this decimal place one place to the right, which means I'm making the first part factor 1 power of 10 larger. So to balance it, I need to make the power of 10 over here smaller, which means I can rewrite this as 4 92 times 10 to the 5th power, or approximately 5 times 10 to the 5th power.